Well, hello everyone, welcome back to Dprieto TV. I hope you like travel tidbits, but finally since January, we are back with Prietology Season 5. Wow, this is the fifth time, this is the fifth season we're doing. This season, like I said, all the way back in January, it's been a while. We're talking about astronomy this time, some great stuff. We're going interstellar, we're talking about the planets, stars, moons, galaxies, even black holes we'll even be able to get into. So yeah, like I said, I hope you enjoy travel tidbits, and remember that this is the last season of Prietology that I will make on this channel. It's expected to last the end of the year, considering how many episodes I'm doing. So yeah, enjoy this last season, the grand finale season. We've talked about chemistry, physics, biology, geology, and now we're doing probably my favorite out of all of them, astronomy. So yeah. Let's go over the key terms. We got some announcements at the end. So yeah, this is episode 1 of 8, just to show you how long this is already. So yeah, let's go over the key terms. I've kind of changed things up a bit. So yeah, let's go. Alright, so as we head into the final season of Prietology, we go over our first episode, the basics of astronomy. So yeah, we have, I'm counting really quick, 7 key terms to start us off. Essentially how we're going to start with the solar system, and we're dividing that up into 3 episodes. This one, we're talking about the inner solar system. So we have Mercury, Venus, Earth, meteorite, the Moon, Mars, and the asteroid belt. Just to start off the solar system. So yeah, let's get started with our first term. Alright, let's start off season 5 of Prietology, term number 1. So yeah, we're talking about good old Mercury, the closest planet to the sun. As we know, our famous solar system, all our planets that surround it, is the closest to the sun, but surprisingly it is not the hottest planet in the solar system. Another cool fun thing about it is that it's named after the Greek Roman god. They share the same gods, the messenger of the gods, Mercury, or Hermes. That's the Greek name of it. Supposedly, or not supposedly, it is very, very hot during the day. Just saying that it's not the hottest planet in the solar system doesn't mean it's burning. High of 806 Fahrenheit is probably the highest ever temperature, so you can imagine a daily temperature. So absolutely scorching during the day and freezing cold at night because it does not have an atmosphere, almost no atmosphere whatsoever. So temperature changes are massive. So burning hot temperatures of 700 degrees during the day, and at night you can get down to minus 200 degrees Fahrenheit at night, because essentially it's bare naked in the vacuum of space. So big temperature shifts in this planet. So one thing that it used to be very while ago, it used to be very hot and molten, being so close to the sun, and now after many years, like thousands of years, the core has cooled down significantly to what it was thousands or possibly millions of years ago, and since that, cold things shrink, so that means the entire planet technically is shrinking with it, causing wrinkles along the surface. So there's a lot of like jagged parts along the surface of Mercury. If you go there, which I don't think you can, because you'll die if you step on there. But yeah, the surface is shrinking. The entire planet is essentially shrinking, so kind of like crumpling itself up, kind of like squeezing itself into itself. So yeah, some fun fact about Mercury. We're continuing fun facts in this season. Some fun facts about Mercury, or a fun fact about Mercury, is that there is ice on its caves in Mercury. Considering that, like I said, anything that essentially is facing the sun gets super hot, but considering the caves, they reach no light, they are not facing the sun, essentially they're facing the vacuum of space every single day, freezing cold, probably the coldest parts on the planet itself. So yeah, pretty cool. Alright, second term, we are going to the second closest planet in the solar system. We're going out of it. Venus, the second closest planet to the sun, named after the Greek-Roman goddess Aphrodite/Venus of love and beauty. It does not live up to its name, surprisingly. It is not loving, it is not beautiful, it is a deadly place. You will never be able to step foot in that. The second you do, you're gone. The hottest planet in the solar system, beating Mercury by over 100 degrees Fahrenheit due to its greenhouse effect. The greenhouse effect is essentially, well, you know greenhouses, that's where you store plants. Like, here's a picture of a greenhouse, that's where you store plants in, so they can get more direct sunlight, more energy from the sun. So how the greenhouse effect works on Venus is that the most of the atmosphere is made out of carbon dioxide, and the other one is sulfuric gas and sulfuric acid, which we'll talk about in a bit. So most of the atmosphere being carbon dioxide, all the heat that reaches it, considering it's pretty close to the sun, it hits it and it's trapped there. That's why they use greenhouses to cover plants, so all the energy of the sun can be there. The carbon dioxide atmosphere traps all the heat inside, so it can't escape almost, and all of it's just locked in and building and building and building and building. And yeah, that's what makes it the hottest. It has a deadly environment. Not just considering the heat, it is also deadly because it has a crushing pressure. All of that carbon dioxide. Carbon dioxide itself is a very heavy gas. There's a lot of stuff in it. And considering that there's a ton of it, almost the entire atmosphere it is the same pressure as 1 kilometer going 1 kilometer under the ocean. Absolutely crushing you. It would crush you in an instant. Has toxic sulfuric acid rain once in a while. By once in a while meaning like almost all the time. It's raining sulfuric acid that'll melt your skin off easy. And yeah, sulfuric acid rain. The air is also super toxic. It's super heated, so it burn your lungs to death. So yeah, named after the goddess of love and beauty, but trust me, it is not loving and it is not beautiful. Fun fact, the highest point is the Gulamons volcano. Yes, there are volcanoes on Venus, another thing that doesn't make it loving and beautiful. Are they active? I am not sure. I think some are, some aren't, so it kind of depends where you are. But yeah, the Gulamons volcano, the highest point on Venus. Not saying that you'll ever be able to see it because rovers and stuff we send in, they last 8 minutes and then they're gone. So yeah, not the most pleasant environment to be in. Yeah, let's move on to our home. Alright, third closest planet to the sun, and our home in this ginormous galaxy we live in this infinite, possibly infinite universe that we live in. Good old Earth. Third planet from the sun, and like I said, our home in the solar system, the galaxy, the universe. The only planet in the entire solar system with surface water, specifically, like you heard what I said, surface water. No other planet has surface water, but I'm not saying that no other planet has water. We'll get into that in a bit, and stay tuned to know other planets that have surface water and other moons as well. It's in what scientists call the Goldilocks range. So Venus, as you know, boiling hot, you die in an instant. Mars, on the other hand, is freezing cold. We'll talk about that in a bit. So it's not too hot like Venus, it's not too cold like Mars or like other planets. It's in the perfect range, perfect temperatures, and that's why I'm able to film this video for you guys, why the camera hasn't melted, why there's electricity, while there's stuff, why I can go outside even though it's 115 degrees outside right now in Arizona, but still survive. The spinning outer core of the Earth, it has the spinning outer core, as you know, the layers of the Earth, it has the crust, the mantle, and the two cores, the outer and the inner core, is made of molten iron. So it's essentially liquid. It's like a Play-Doh consistency. It's super thick and obviously boiling hot. It rotates around it, and that creates the Earth's magnetic field / current. All the current of the magnetic Earth, all the fields that we have created, that is created by the spinning outer core. And those magnetic fields help block the Earth from radiation and all the deadly like radiation and UV rays that are bombarded by the sun. So yeah, good thing that we have a spinning outer core. Otherwise, we would die. All right. Fun fact, there is actually something called an astronomical unit. It's a measurement of unit, and that is the same distance as, it's actually defined as the distance between the sun and the Earth. That is one astronomical unit. One astronomical unit, the sun and the Earth distance. Yeah, that is used to measure galaxies and other solar system distances, star distances, a ton of other stuff. So yeah, it is pretty big considering it's millions of miles. So yeah, that just tells you how powerful the sun is. Being millions of miles away, we're still able to get its gravity and still able to receive its heat and energy. So yeah, let's move on to some other cool ones. Alright, we are on term number 4. We got 3 left to go. Meteorite. That's not a word you hear every once in a while. Essentially, in a simple layman's terms, it's a space rock. Literally. That's almost a way to define it. I actually saw that's essentially the definition. It's a space rock. It's a rock that comes from space, and it's usually the small rocks that make it all the way to the surface. Now, this is something I really want to talk about, the definition or the difference between meteorites, comets, and asteroids. You would think, oh, they're just all the same thing. No, they're not. Like I just said, meteorites are space rocks that come all the way down to the surface and hit it. Small space rocks, not like the one from Armageddon the size of San Francisco or something like that. Small space rocks that come and hit the surface, that make it all the way through the atmosphere, and those are the ones that usually make craters on the Earth. Like there's a crater not too far from here in Arizona, I think. Comets are essentially snowballs. They're essentially just balls of ice and rock, primarily ice, that shoot along through, that pass by planets. Like, you wouldn't usually see a comet passing through here. Like Halley's Comet, that's a famous one passing by here. And I think in the next 40 years it'll come back. So yeah, essentially mostly snowball. They have the tails, the melting ice and the heat created by the sun is what makes the tail. And yeah, and asteroids are the ones that you see in movies that destroy the Earth, like Armageddon or Deep Impact or something like that. So, and the ones that are usually in the ones that usually burn up in the atmosphere, those are usually meteors, not meteorites. Meteorites are the ones that get all the way down to the surface. Meteors are the ones that get into the Earth, small space rocks, but burn up in the atmosphere because there's so much friction. Also known as shooting stars. That's what a lot of people like to call it. That's actually what I call it. Scientists also say that sometimes meteorite can be its own rock. Usually it's not something that can be found here, so essentially sometimes they classify meteorite as their own rock, like something called regolith. It's a type of stone here, I'll put it right here, regolith. It's a type of stone, it's found on the moon actually, which we'll talk about in a bit. It's called regolith. It's usually something that makes up meteorites, a lot of space stuff, a lot of space rocks, comets, ice. The moon is made of regolith, yeah. It's a stone usually primarily found in space. Alright, fun fact about meteorites, the biggest crater is actually here in Arizona. The biggest crater of a meteorite made is here in Arizona. It's called Barringer Crater. It's in Barringer? Well, I don't know if it's called Barringer Crater, but it's in a place called Barringer, Arizona. I have no idea where that is. I've never been to it. But yeah, interesting. So yeah, let's keep talking about space rocks with a pretty big one coming up. Alright, like we just talked about space rocks. Here's a pretty big one. It orbits us. The moon. It's a pretty big one. You see it almost all the time. It's everywhere. It's been here for like the past supposedly thousands of years. It is the Earth's only, as the scientists call it, natural satellite, if you want to be fancy. Natural satellite essentially means something that orbits the Earth, a satellite, but it's natural, so it's not man-made. And one of 3 moons in the inner solar system. We'll talk about the other 2 in a bit. So it's one of 3 moons in the inner solar system. It has no atmosphere, which means it has no sound. You don't hear a thing when you're on it, and no wind. So all the footprints and stuff and tire tracks left by rovers and footprints by the astronauts on the moon, they are still there, which to me is pretty cool. It's pretty cool that they're still there. You can go see them, but it's kind of expensive to get up there. It's billions of dollars. So yeah, and it does not produce its own light. The way you're able to see the moon is that the sun, the light of the sun reflects off of the moon, and you're able to see it in the night sky. And like I said, it's also made of regolith, which is kind of like one of the main stones that make up meteorites. So yeah. And also it makes waves, not as in like stadium waves where you go like that. It literally makes waves. The moon's gravity pulls on the Earth's and literally makes ocean waves. So when you go to the sun, when you go to the beach, you see the waves pulling along the surface. You can thank the moon for doing that. And that's why at night, that's why they say at night it's usually high tide, because that's when the moon comes up. And since the moon is literally directly above, it makes the waves much larger and they go much higher above the surface. So yeah, that's why the later it gets, the much bigger the waves go, the much farther they can travel. So yeah, fun fact. You ever heard of earthquakes? We have ours here. The moon also has earthquakes. It has about 1,500 per year. But instead, since these are earthquakes and that's the moon, they're called moonquakes. Try saying that, it's a cool word. Moonquakes. That's an interesting word. 1,500 per year. Yeah, it's usually caused by internal stuff, gravity. Jupiter's gravity kind of has an influence on it, but it's a little too far for that. So yeah, maybe not. It's usually more the Earth's gravity. Alright, turn number 4. This is a planet that's usually in all those space travel movies. It's probably the second most habitable one after the Earth, but it's not really that habitable. The Red Planet, the god of war himself, named after the Greek god of war. Mars, or Ares. The fourth closest planet to the sun. It's kind of cold. Usually, you know the temperatures of Antarctica? That's about the average daily temperature on Mars. So pretty cold, and it gets colder, like minus 100 degrees Fahrenheit. So not the most gentle environment, but hey, somewhat habitable. Atmosphere, or the air usually around it, is carbon dioxide, so sadly we can't breathe it. But yeah, pretty cold there, about carbon dioxide air, so yeah, not that habitable. It used to be a planet with water flowing everywhere, rivers and stuff like that. Didn't have plants, it's just rocks. But now it's dead. There are just remnants of volcanoes, valleys and stuff like that. They're just dead. They don't work anymore, but they don't work anymore. They're not active anymore. So yeah, just sitting there essentially, just collecting dust and wind. It has water ice, which is essentially water in ice form. They call it water ice because in the solar system there are many forms of ice. There's methane ice, I think there's nitrogen ice, like frozen nitrogen, there's carbon dioxide ice. So just to be specific with which type of ice you talk about, water ice, or aka ice that we usually just go, like the ice that you put in your lemonade. It's usually, as you've heard it called many times, the red planet. It is called the red planet because of a chemical called iron oxide, also known as Fe2O3. I think I got that right? Yeah, okay. Iron oxide that makes, or as you guys know it probably, rust. Iron oxide is the same as rust. It makes the earth, or makes things metal, makes them corrode, makes them give them an orange-red look. The surface of Mars has iron oxide, giving it that red look. It's essentially a rusted, old, dead planet. So, yeah, that's kind of usually it of it. It has 2 moons that are shaped literally like potatoes. Like, they're like elongated like this. Phobos and Deimos, the other 2 moons that make up the inner solar system along with our moon. So yeah, there's the only 2. All the ones in the gas giants. There are hundreds of moons, which we'll all talk about. Not all of them, though. Fun fact. Olympus Mons. It's a mountain. It's called Olympus Mons, which is probably named after Mount Olympus, which is the Greek god, the Greek mountain where all the gods live. Olympus Mons is the tallest mountain on Mars and the tallest mountain on the solar system. It is the last of the terrestrial planets. It is the tallest mountain there. 3 times the height of Mount Everest. Even if you see satellite images of Mars, it peers through the atmosphere like you could see it from space, literally. It's huge. It used to be an old crater. It has craters on top of it. Volcano. I think it used to be a volcano, actually. So yeah, it is ginormous. It's 3 times the solar system. It's the tallest mountain. Yeah, we got 1 more term to go, and yeah, we wrap up the inner solar system and the first episode. So yeah, let's do the last term. Alright. Final term of episode 1 of season 5, the basics of astronomy. We're essentially going out of the planets that we know, and we're going to essentially what is the border between them? The asteroid belt. It is literally the border between the inner solar system and the outer solar system. That's what defines it. It is essentially a large ring of rocks, so you can imagine your solar system and then just the inner solar system, and then essentially a large ring surrounding that inner solar system, and then their other planets and all the ice giants and outside. So it's a large ring of rocks between Mars and Jupiter, like I said. There is actually a planet there. It is not a planet in the solar system, so don't get confused. It's called a dwarf planet, essentially what is Pluto. It's a dwarf planet called Ceres. It's pretty small. It's not like anything habitable where we can go. It's essentially just a rock, no atmosphere like the moon. And it's very small. It's a dwarf planet. It was promoted to a dwarf planet in 2006. Fun fact. Because of Jupiter's gravity, which isn't that far from it, the asteroids and the ones that are usually around the asteroid belt, they're always crashing into each other and shattering. Not as much from Mars's gravity, because that isn't as strong. That is like microscopic gravity compared to Jupiter's ginormously huge gravity. So yeah, that's where all the asteroids that are usually there to get influenced by Jupiter's gravity. Of course, they orbit around the sun. Well, I don't know if they orbit, they just stay put. They just crash into each other and stuff like that. So yeah, that just tells you how big Jupiter is, how its gravity can influence something that's millions of miles away. Yeah, that is pretty interesting indeed. Some of the asteroids in the asteroid belt are considered to be something called NEA, which I'll put it here, NEA, which are also known as near-Earth asteroids. So yeah, they're near the Earth. So yeah, they're not going to usually hit it, which actually brings me to my fun fact. So a fun fact about asteroid belt, a 165 foot wide NEA, or near Earth asteroid, I'm pretty sure that lives up to its name. It passes near the Earth. It strikes Earth every 1,000 years. So approximately every 1,000 years, a 165 foot asteroid called an NEA strikes the Earth, which I'm guessing that hasn't happened for 1,000 years. Yeah, it's been a while, so yeah, pretty interesting. Alright, so yeah, we finished our key terms, all 7 of our key terms for this episode, so yeah, let's move on to announcements. Alright, so yeah, that is a wrap on episode 1. We have started season 5. It's so crazy to think about that. just 3 years ago when the pandemic started in the spring. I started the series with season 1 in chemistry, and now we are 5 seasons into it. So yeah, thanks for coming along, guys, for this journey. But yeah, let's go over some announcements. The next video that will be back, we are going back to gaming, so get excited for that. Turmoil number 5, Turmoil gameplay number 5. We're going back to Turmoil. I was supposed to do it before we went to Mexico, but unfortunately I didn't have time. I had academic stuff to do. So yeah, gameplay number 5 of Turmoil coming to you on August 13th. So August 13th, Turmoil number 5. And also, I don't know if you saw, but I put a community post a while back that said that I am no longer going to be putting videos or playing F1 2021 or Surviving Mars. They don't interest me that much anymore, and videos sometimes take a bit too long to edit. So yeah, unfortunately those series will be discontinued, so that just leaves us with Turmoil, Cuphead, Stardew Valley, and Burnout Paradise. That's the last one. I might add another gaming series this year or maybe next year, maybe around the winter, maybe next year. So yeah, who knows? I'll have to see. I'm thinking of some games maybe to add. So yeah, we'll have to see about that. So yeah, next episode, season 5 episode 2, that is coming out in a little bit. I'll talk about that in the next video. We are going to talk about solar system. We are continuing our tour of the solar system. We're going to go to the gas giants next. So Jupiter, Saturn, Uranus, and Neptune. We're talking about those bugs and other stuff that consider in the gas giant range. So past the asteroid belt, other things like Jupiter's moons, Europa, Titan, some cool ones, and a space probe that went there a while ago. We'll talk about that as well. So yeah, thanks for watching. Thanks for coming back for Prietology. It's great to be back. It's great to do this again. This is something I really enjoy doing, and hopefully you do as well. But yeah, I will see you in 2 weeks for Turmoil gameplay number 5. So yeah, see ya, and remote.
Yeah.